Welcome back, my algebra friends. And you know what? Today we're really going to dive into, well, it says monomials, but don't let that word fool you. It's really, when we're talking about monomials, we're typically looking at something that has some exponents involved. And that's what we're talking about today is exponents. So I have over here on the side, I have written out x to the third power. I just want to remind you that we have some vocabulary that's important. The x, or what is being multiplied, this is the base. So when we're talking about common base or like bases, we're talking about that variable usually, or it could also be a coefficient. And then this 3, well, the 3 is the exponent. It's being raised up to an exponent or being multiplied out. Now, if you see the word power, because when we say, a lot of times we'll say x to the third power, power just implies the entire thing. So when you add a base and an exponent, you put them together, that's actually considered a power. So it's just another vocabulary word you might hear. I want to make sure you're aware of what it means. So to multiply monomials, use the product rule. Well, we're going to do that, but first I want to look at number 17. Let's just think this through. I have x to the second times x to the third. Well, if I was to write that out, expanded form, this would be x times x, right? That's what x to the second means. And then times x to the third, so 3 more x's. It's all multiplication. If we multiply all of that together, how many x's do we have? Yeah, we have x to the fifth, right? Well, look at those exponents, 2 and 3. If I add those together, 2 and 3, I would have x to the fifth. That seems a little bit easier than writing it all out, but we're going to try it again. A to the ninth, so I'd have 1a, 2, 3, 4, 5, 6, 8, 9, and times a. A, that's just an a. Now remember, anything that's just a variable has an exponent of 1, so there's 1a there being multiplied. Now, if I count all those up, how many a's am I multiplying? Well, I'm multiplying 10. So another way of thinking about that is if I just add my exponents of my common base, a and a, common, 9 plus 1 is 10. So in the next one, we could write it all the way out and count them all up. Or we could say, you know what, I have a common base. I have a w and a w. If I take a w and a w, I'm going to keep the base. I'm going to add the exponents. And 7 plus 4 is 11. So our rule back at the top here is if I have a common base, my common base here was x, I can take the exponents and I can add them together. So x raised to the power of a plus b. So next we want to take a look at examples with coefficients. Now you will not always have a coefficient, like numbers 17 through 19 here. You won't always have coefficients. Sometimes you'll just have variables. But coefficients add a little bit of, we got to go back and think, how do we combine coefficients? And we're just multiplying here. Everything that's happening in these problems right now are multiplication. So if I look, this would be the same as writing 4 times x times 3 times x times x times x times x times x. We could rearrange this and put everything together the way it needs to be. We could say, well, that's the same as 4 times 3. We're going to put the coefficients out front, and then we're going to rewrite all of these x's. That's going to take a lot of time. So let's just think. I have 4 times 3. My coefficients, if they're being multiplied, I just multiply them. What is 4 times 3? 12. I'm going to keep the common base of x. That's what has the actual exponent, right? I have an x2 and an x to the fifth. I'm just going to combine them together. I'm going to add them up, and that would be 2x to the seventh. Pause the video. Think about that. Coefficients multiply, and then look at your variables that have the exponents, okay? And look at 21 and 22. All right, in 21, we had 3 times 5. Well, 3 times 5 is 15. I have a common base of x, so I'm going to keep the x, and then I'm multiplying the x to the 6th times x to the 2nd, so I'm going to add those exponents, so x to the 8th. And in 22, we have 5 times 6, 30. X raised to the 2nd times x raised to the 4th. We're going to keep the common base of x. We're going to add the exponents. So let's look at our next set here. I'm going to probably move it around a little bit, right? Number 23. Well, it's still multiplication. Everything there is being multiplied. So I'm just going to multiply my coefficients. So if I multiply -4 and 3, I get -12. Now, common bases. I have an A and an A, so I'm going to keep that A and add their exponents, 3 and 2, which is 5. I have a common base of B. I'm going to keep the B and add the exponents. Now be careful, if it helps you remember, add your 1. Remember that B is there. That B has an exponent of 1. So 1 plus 5 is 6. So -12, A to the 5th, B to the 6th. Pause the video, try 24 and 25. All right, in 24, -7 times -4, +28. I look at my common bases. I have a P and a P, so I'm going to keep the P. 9 and 2, when I put those together through multiplication, I actually add them. So 9 and 2 are 11. Q was 3 and 6, so I keep the Q. 3 plus 6 is 9. And then I have an R. So R has raised to the 1, raised to the 4. I combine, and that's a 5. 25. 8 times -3, -24. I have an x to the 4, x to the 4. When I put those together, that's x to the 8th. Remember, we're adding them. And then y to the 2nd times y to the 9th. We're going to add those up in the exponents and keep that common base of y, so y to the 11th. So I'm going to challenge you here for a little bit. Go ahead and work the next couple of lines. So 26 through 31 here I have up on the screen. Pause, work each one, and then come back. Okay, so again, we're just multiplying. We don't have anything else wrapped up in here right now. With multiplication, we find the coefficients. Remember the numbers in front of the variables, we multiply them together, and then we find that common base. Whatever the common base is, we can either expand it out and count them all, which sounds like a long time, or we can keep the common base and we can add up their exponents. The key here that I think that is the most confusing is, remember, when there's not an exponent, go ahead if you need to and write in the 1. So like on 26, I might have said, well, that's y to the 1st power. Don't forget, every variable has an exponent. If you don't see it, it's a 1. So double check 26 through 31 here. And then we are going to take a look at number 32 through 34 together. They're just a little different. Well, not really. We just showed up with some fractions. And I know we don't like fractions much, but we have to get our fractions ready. So I'm going to remind you here in number 32, I have -6 times 1/2. Well, you could think of what's half of 6, right? 3. So -3, again, keeping the A to the 3rd, and a B, and I have B and B, so that'd be B to the 2nd. Now that one, when you think half of 6, that might be a little easier. But now in 33, I've got 12 times 2/3. Remember, 12 times 2/3, you could put it over 1. You could multiply straight across, which is 24 over 3, which simplifies to 8. So think about your fractions. You can set them up as those whole numbers, turn them into fractions. Or you could even cross cancel. I don't know if you remember doing that before. If I was to cross cancel, I'd be, oh, there's a 12 and a 3. I can put 3 into both. And then I would have 4 times 2, which is 8, and 1 on the bottom. And so 8 divided by 1 is 8. That's just a quick fraction refresh. So my final answer here would be 8 once I got my coefficient right. And then I'd have x, y to the 5th. Now 34 is a little different in the fact that you have 3 numbers, but that's okay. You can kind of pick and choose how you want to put those together. I'm looking at a 1/4 of 8, and I have a -6. Well, 4 goes into 8 pretty easy, right? A 1/4 of 8. So 1/4 times 8, which would be 8 over 4, which is 2. And then I still need to multiply that times -6. So 2 times -6 is -12. So I'm going to go ahead and get that coefficient set up, and then I'm going to go back and look at my exponents. I had common base of m, then m to the 3rd, and then I have n's. So that's 1 n and 2 n, so that's 3 n's. So be careful with your fractions. You remember the last time you looked at these, I know it's been a couple days, we looked at adding and subtracting. And I want to take a look at that again because I think it's important that we can combine our skills. I want to remember way back when we are simplifying. And I know I'm simplifying because there's no equal sign. We just have expressions. We're just putting it all together. We're not moving anywhere. We're just putting it together. So if I look here at number 35, I notice that I have two sides. I have addition in the middle and multiplication and multiplication. Well, according to our rules of order of operations, we have to multiply before we can add. So in these types of problems, you would multiply each side and then you would add them together. So 2 times 4 is 8. That's x to the 6th, y to the 2 and 3 is 5. Plus, we haven't done anything with that yet. So 3 times what? Yeah, that's kind of tricky. Remember there's a 1 out here when there's nothing out there. So it's just 3. 3 times 1 is 3. Then I have x, 4 and 2, which is 6. And I have y to the 4th and y. So that would be y to the 5th. Now think. Are these exactly alike? They are. X to the 6th, y to the 5th, x to the 6th, y to the 5th. We can now combine like terms. Remember, when we combine like terms in adding, we do not change exponents. We just add the coefficients. 8 and positive 3 are 11. Coefficient 11, exponents here. X to the 6th, y to the 5th. Again, we did not change them because we're adding them. We do not change exponents when we are adding and subtracting. We just combine like terms. Sometimes they get long and complicated, but you just got to be very methodical or very strategic and think one step at a time. So I want you to pause and try number 36 real quick. Again, order of operations. We multiply everything that needs to be multiplied before we can add. So think about it in sections. We're going to do all the multiplication where the multiplication is present in the problem, and then we can start adding things together. Once we have multiplied, we have common variables. With common variables, those are called like terms. So we can just combine them up. So go ahead and take a look at number 37. Be careful with that subtraction, but just the same rules. Think about what can I multiply? And maybe you don't have to multiply everything. Maybe you just have to multiply one side. All right, 37 looks like 19 m to the 8th, n to the 8th, subtract 12 m to the 8th, n to the 8th. We have like terms, so we're going to subtract. And 19 minus 12 is 7. Keep those variables just the way they are. And at number 38, when we multiply it out, and then we simplify. So we have that 15 minus 14 because our variables are exactly alike, so we can put it together. 15 minus 14 is 1. Remember, we don't actually write the 1 unless we need to if it's the only thing left. So we just have c to the 5th, d to the 2nd. So exponents. Remember, we have a base, we have an exponent. When we're multiplying, our product rule for multiplication, we're just going to slide all the way back up here. Our multiplication, we just keep the common base and add the exponents. If there's a coefficient, we multiply the coefficients, the number out front, and then we still follow the product rule for the variables.